Welcome to DCE Digital Learning. This is Bachelor of Science Mathematics Theory of Equations class, and in this class we are going to discuss solution of cubic and biquadratic equations when roots are complex numbers. Recap. The imaginary roots, if any, of an equation with real coefficients occur in conjugate pairs. This is complex conjugate root theorem. If alpha plus I beta, where alpha, beta are real numbers and beta is not equal to 0, is a root of f of x equals 0 with real coefficients, then alpha minus I beta is also a root of f of x equals 0. For equation with rational coefficients, irrational and imaginary roots, if any, occur in conjugate pairs. Every equation of odd degree with real coefficients has at least one real root. Let's move to problems. Problem 1. Form a cubic equation with real coefficients given that 2 and 1 plus 2i are two roots. Solution. First we observe that a cubic equation has three roots. Two roots are given as 2 and 1 plus 2i. We need one more root. The imaginary roots of an equation with real coefficients occur in conjugate pairs. Hence, 1 minus 2i must be the third root of required cubic equation. Therefore, required cubic equation has roots 2, 1 plus 2i and 1 minus 2i. So, the required equation is x minus 2 into x minus 1 plus 2i into x minus 1 minus 2i equals 0, which implies x minus 2 into x minus 1 minus 2i into x minus 1 plus 2i equals 0, which implies x minus 2 into x minus 1 whole square plus 4 equals 0. Which implies x minus 2 into x square minus 2x plus 1 plus 4 equals 0, which implies x minus 2 into x square minus 2x plus 5 equals 0, which implies x into x square minus 2x plus 5 minus 2 into x square minus 2x plus 5 equals 0, which implies x cube minus 2x square plus 5x minus 2x square plus 4x minus 10 equals 0, which implies x cube minus 4x square plus 9x minus 10 equals 0. Therefore, required cubic equation is x cube minus 4x square plus 9x minus 10 equals 0. Problem 2. Form a biquadratic equation with rational coefficients given that root 3 and 3 plus I are two roots. Solution. First we observe that a biquadratic equation has four roots. Two roots are given as root 3 and 3 plus I. We need two more roots. Irrational roots and imaginary roots of an equation with rational coefficients occur in conjugate pairs. Hence, minus root 3 and 3 minus I must be other two roots of required biquadratic equation. Therefore, required biquadratic equation has roots root 3, minus root 3, 3 plus I and 3 minus I. So, the required equation is x minus root 3 into x plus root 3 into x minus 3 plus I into x minus 3 minus I equals 0, which implies x minus root 3 into x plus root 3 into x minus 3 minus I into x minus 3 plus I equals 0, which implies x square minus 3 into x minus 3 whole square plus 1 equals 0, which implies x square minus 3 into x square minus 6x plus 9 plus 1 equals 0, which implies x square minus 3 into x square minus 6x plus 10 equals 0, which implies x square into x square minus 6x plus 10 minus 3 into x square minus 6x plus 10 equals 0, which implies x raised to 4 minus 6x cube plus 10x square minus 3x square plus 18x minus 30 equals 0, which implies x raised to 4 minus 6x cube plus 7x square plus 18x minus 30 equals 0. Therefore, required biquadratic equation is x raised to 4 minus 6x cube plus 7x square plus 18x minus 30 equals 0. Problem 3. Solve x raised to 4 plus x cube minus 25x square plus 41x plus 66 equals 0, given that 3 minus I root 2 is a root. Solution. First, we observe that a biquadratic equation has 4 roots. One root is given as 3 minus I root 2. Imaginary roots of an equation with real coefficients occur in conjugate pairs. Therefore, 3 plus I root 2 must be another root of given equation, which implies 3 minus I root 2 and 3 plus I root 2 are two roots of given equation. Therefore, x minus 3 minus I root 2 and x minus 3 plus I root 2 are factors of given equation. Hence, x minus 3 minus I root 2 into x minus 3 plus I root 2 equals x minus 3 plus I root 2 x minus 3 minus I root 2, which is equal to x minus 3 whole square plus 2, which is equal to x square minus 6x plus 9 plus 2, which is equal to x square minus 6x plus 11 is a factor of given equation. Dividing LHS of given equation, x raised to 4 plus x cube minus 25x square plus 41x plus 66 by x square minus 6x plus 11, we have x raised to 4 plus x cube minus 25x square plus 41x plus 66 equals to x square minus 6x plus 11 into x square plus 7x plus 6. We can employ synthetic division or long division for the division. Equating the coefficient to 0, we have x square plus 7x plus 6 equals 0. This quotient is a quadratic equation. We can solve this either by quadratic formula or by factorization. Using the quadratic formula, x equals minus b plus or minus square root of b square minus 4ac by 2a, we get roots of above quadratic equation as minus 6 minus 1. Therefore, required roots are minus 6 minus 1, 3 plus or minus I root 2. Problem 4. Solve x raised to 4 minus 8x square plus 36 equals 0, given that I plus root 5 is a root. Solution. First, we observe that a biquadratic equation has 4 roots. One root is given as I plus root 5. Irrational and imaginary roots of an equation with rational coefficients occur in conjugate pairs. Hence, I minus root 5 minus I plus root 5 minus I minus root 5 must be other roots of given equation. Since given equation has 4 roots, all roots are I plus root 5, I minus root 5, minus I plus root 5, minus I minus root 5. Problem 5. Find all the roots of the equation x raised to 4 minus 6x cube plus 18x square minus 30x plus 25 equals 0 if the roots are of the form alpha plus I beta, beta plus I alpha, where alpha beta are real. Solution. First, we observe that a biquadratic equation has 4 roots. Two roots are given as alpha plus I beta, beta plus I alpha. Imaginary roots of an equation with real coefficients occur in conjugate pairs. Hence, alpha minus I beta, beta minus I alpha must be other two roots of given equation. Now, sum of the roots equals minus coefficient of x cube by coefficient of x raised to 4, which implies alpha plus I beta plus beta plus I alpha plus alpha minus I beta plus beta minus I alpha equals 6, which implies alpha plus beta equals 6, which implies alpha plus beta equals 3, which implies beta equals 3 minus alpha, equation 1. Next, product of the roots equals constant by coefficient of x raised to 4, which implies alpha plus I beta into alpha minus I beta into beta plus I alpha into beta minus I alpha equals 25, which implies alpha square plus beta square into alpha square plus beta square equals 25, which implies alpha square plus beta square equals plus or minus 5. Since alpha beta are real, alpha square plus beta square equals 5, equation 2. From 1 and 2, we have alpha square plus 3 minus alpha whole square equals 5, which implies alpha square minus 3 alpha plus 2 equals 0, which implies alpha equals 1 or 2, which gives beta equals 2 or 1. Therefore, 1 plus 2i, 1 minus 2i, 2 plus I, 2 minus I are the required roots. Problem 6. If B and C are real and 2 minus square root of minus 3 is a root of the equation x cube plus x square plus bx plus c equals 0, what are the other roots and what is the value of c? Solution. First, we observe that coefficients are real. One root is given as 2 minus I root 3. Imaginary roots of an equation with real coefficients occur in conjugate pairs. Hence, 2 plus I root 3 must be another root of given equation. Now, sum of all the three roots equals minus coefficient of x square by coefficient of x cube, which is equal to minus 1. Therefore, 2 minus I root 3 plus 2 plus I root 3 plus third root equals minus 1. On simplification, third root equals minus 5. Therefore, required other roots are 2 plus I root 3 and minus 5. Next, product of roots equals minus constant by coefficient of x cube, which is equal to minus c. Therefore, 2 minus I root 3 into 2 plus I root 3 into minus 5 equals minus c, which implies c equals 4 minus minus 3 into 5, which implies c equals 35. That's all in this video. Thank you.